students, in our previous video, we have studied about the different allotropic form of phosphorus. Now, in this video, we'll study about a very important product of phosphorus, which is known as phosphine and have a formula pH3. We'll study all about the phosphine in this video. So, let's begin. Here is our topic, that is phosphine. First of all, we'll talk about the preparation of phosphine. We can prepare phosphine by the following methods. We have 4 or 5 methods for the preparation of the phosphine. We'll study these methods one by one. First of all, by the action of water or dilute acid on metal phosphide. So when we react metal phosphide with water or dilute acid, then we get phosphine. Like suppose Ca3P2, this is the metal phosphide of calcium. When it reacts with water, then it forms CaOH whole twice plus pH3. And suppose metal phosphide when reacts with HCl, then it forms MgCl2 plus pH3. So the first method is by the action of the water or dilute acid on metal phosphide, we can prepare phosphine. Now the second method is by heating phosphorus acid. Second method is by heating phosphorus acid, that is H3PO3. This we studied previous also, that H3PO3 on heating undergoes disproportionation reaction, and if we talk about H3ASO3, H3SbO3, H3BiO3, then down towards the tendency to undergo disproportionation reaction decreases. So when this H3PO3 on heating gives H3PO4 plus pH3. So this is a kind of the disproportionation reaction, a reaction in which a single substance undergo both oxidation as well as the reduction. So in this, by this method also we can prepare phosphine. Now, third method, by reduction of PCl3 with LiAlH4. By the reduction of PCl3 with LiAlH4, when PCl3 undergoes reduction with LiAlH4, then it forms PH3 plus LiCl plus AlH3. Clear? So in this way also we can prepare phosphine with the help of the phosphorus trichloride by the reduction of the phosphorus trichloride with lithium aluminium hydride. Now the fourth method which is very important method. This is from phosphonium iodide. Now, why this method is very important? Because through this method, we can prepare the purest form of phosphine. We get the purest form of phosphine through this method. Now, what is phosphonium iodide? Phosphonium iodide is PH4I. By heating phosphonium iodide with concentrated NaOH, we get pH3. By heating phosphonium iodide with concentrated NaOH, we get pH3 in the vapor form. Along with the pH3, we get NaI and H2O. So in this way, we get the purest form of phosphine through this method. So from phosphonium iodide, we can prepare phosphine, and this is the method through which we can prepare the purest form of phosphine. Now next, we'll study the fifth method, that is the laboratory method. Fifth method, that is the laboratory method. Now, in laboratory, we prepare phosphine from the white phosphorus. We prepare phosphine from the white phosphorus by heating white phosphorus with concentrated NaOH solution, in the inert atmosphere. In the inert atmosphere, we get phosphine. So what is the reaction? Reaction becomes P4 plus NaOH. Now this one is the concentrated NaOH solution. So it is solution, so therefore H2O. On heating in inert atmosphere of CO2 or gasoline, means in CO2 or gasoline. Clear? We get PH3 plus what we get? NaH2PO2. This reaction also we have studied in our previous video, that when white phosphorus reacts with the concentrated NaOH solution in an inert atmosphere, then it undergoes disproportionation reaction and one of the product is phosphine. But the phosphine which we get from the lab is not pure. Clear? Is not pure. Now we'll discuss this role of this gasoline. The role of this gasoline. What is the role of this gasoline? The PH3 which we get from this method is not the purest form of PH3. How we get to know that this is not the pure form? Because the purest PH3 is inflammable. Means purest PH3 doesn't catch fire in the air. But this PH3 readily catches fire in the air due to the presence of P2H4 as an impurity. This PH3 contain P2H4 as impurity. This PH3 contain P2H4 as an impurity, and due to the presence of this impurity, it readily catches fire in the air. So to prevent this reaction, means to prevent this inflammability, to prevent this reaction, the gasoline is used. So gasoline prevents the catching fire tendency of this gas by reacting with P2H4. Now we have other method also for the purification of this gas. Besides gasoline, we have other methods also for the purification of PH3. So what is the role of gasoline? Gasoline prevents PH3 to catch fire, to readily catch the fire in the air because of the presence of the P2H4 as an impurity. Now we have two different methods also. For the purification of this PH3. The first method is by passing gas through freezing, by passing gas through a U-tube, kept in a freezing mixture. What we'll do, we'll take a freezing mixture and we'll kept a U-shaped tube in that freezing mixture. Then we'll pass this gas, means this impure gas, from one corner of the U-tube, and while passing, the P2H4 which is present in the impure gas gets freezed. Clear? Whereas the PH3 gas will pass out. Clear? P2H4 in this, the P2H4 freezes, whereas the PH3 passes. So in this way we will get the pure form of PH3. Or we can also purify this gas by treating this gas with hydrogen iodide. When this gas, means impure gas, when this impure gas reacts with hydrogen iodide, it forms phosphonium iodide. And when this phosphonium iodide reacts with concentrated NaOH, then it forms PH3, which is the purest form of the iodine, along with the NaI and H2O. So we have three methods through which we can purify the phosphine which is prepared in the lab. First, by the use of the gasoline. Second, by using a freezing mixture. And third, by treating with hydrogen iodide. through these three methods we can purify the phosphine gas which we get from the laboratory method. Next, we will talk about the properties, physical properties of phosphine. Physical properties of phosphine. Now, if I talk about the physical properties of phosphine, the very first property is it is colorless gas, and second, it has an unpleasant smell similar to that of the rotten fish. Similar to that of the rotten fish. Rotten fish. So it is a colorless gas. First of all, it is a colorless gas. Second, it has an unpleasant smell similar to that of the rotten fish. Third property, it is slightly heavier than air. It is slightly heavier than air, means it is slightly denser than air. Next property is it is poisonous. This gas, that is pH3, is poisonous. And the fifth property is slightly soluble in water. Slightly soluble in water, but soluble in CS2. So these are the physical properties of the phosphine. Colorless gas, have unpleasant smell similar to that of the rotten fish, slightly heavier than air, poisonous, and slightly soluble in water but highly soluble in carbon disulfide. So these are the 5 methods through which we can prepare phosphine, and these are the 5 physical properties. Now we will study the chemical property and the uses of the phosphine. Properties of phosphine is basic nature. First is basic nature. In the anhydrous form, it reacts with the mineral acid to form salt and hence behave as an acid. But the condition is the condition should be anhydrous. So in the anhydrous form, the phosphine reacts with the mineral acid to form the salt. This X may be chlorine. This X may be chlorine, bromine, or iodine. So this pH4 X negative may be phosphonium chloride, phosphonium bromide, or phosphonium iodide. So the first property is basic nature in the anhydrous condition. What is the condition here? The phosphine should be present in the anhydrous form. So in anhydrous condition, phosphine reacts with the mineral acid to form pH4 X negative, that is the salt. So this salt may be phosphonium chloride, may be phosphonium bromide, may be phosphonium iodide. Now the second property is combustibility. So if I talk in room temperature, so at room temperature the phosphine is quite stable, but it catches fire on heating. So at room temperature it is stable, but on heating it catches fire. So pH3 on heating with O2 gives H3PO4. So it is stable at room temperature, but it catches fire on heating. Now next, third, if I talk about the decomposition process, then the phosphine, in combustibility we have studied that at room temperature it is stable, but on heating it catches fire. So if we talk about the decomposition, in the absence of air, if we heat the phosphine at 713 Kelvin, it gives P4 and H2. It undergoes decomposition. So when we heat pH3 at 713 Kelvin, in the absence of air, it gives P4 and H2. So the reaction becomes PH3. On heating at 713 Kelvin, it gives P4 and H2. But the aqueous solution of PH3, the aqueous solution of PH3, it decomposes in light. It decomposes in light to produce red phosphorus. So the reaction becomes PH3 H nu gives P4 plus H2. This is red phosphorus, and this one is the aqueous solution. So in decomposition, if it is not in the aqueous solution, on heating in the absence of air at 713 Kelvin, it gives P4 and H2. And if it is in aqueous solution, then it decomposes in the presence of the light and produces red phosphorus. So in this way, the decomposition process will occur. Now next, if I talk about the reaction with chlorine, the fourth point is the reaction with chlorine. So it reacts with chlorine to form PCl3 and PCl5, but on heating. On heating, it reacts with Cl2 to form PCl3 and PCl5. It reacts with Cl2 on heating to form PCl3 and PCl5. On heating, it will react not at room temperature. Now, the reaction of PH3 with HNO2 and HNO3. Reaction with HNO2 and HNO3. When the phosphine reacts with HNO2 and HNO3, it reduces HNO3 and HNO2 to N2 and itself get oxidized to H3PO4. So the reaction becomes PH3 plus HNO2. It gives H3PO4 plus N2. Similarly, PH3 plus HNO3, it gives H3PO4 plus N2. So in both the case, it decomposes HNO3 and HNO with metallic salt solution. Next is reaction with metallic salt solution. Now when it reacts with the metallic salt solution, it forms the PPT of the corresponding metal phosphide. When phosphine reacts with the metallic salt solution, it forms the PPT of the corresponding metal phosphide except silver. Now, suppose if I have CuSO4, then CuSO4 reacts with PH3. This CuSO4 reacts with PH3, then it forms H2SO4 plus Cu3P, and this we get in the PPT form. Similarly, suppose I have HgCl2. This HgCl2, when it reacts with phosphine, it gives HCl plus Hg3P2, and this Hg3P2 I'll get in precipitate form. But if I'll react AgNO3 with PH3, then it gives what it gives. Otherwise, according to this reaction, what we have to get? We get HNO3 plus Ag3P. But we get Ag3P dot 3AgNO3 plus HNO3. And when this that is Ag3P dot 3AgNO3, this reacts with oxygen, then it forms the PPT of silver, not silver phosphide. In other metal salt solution, we get the PPT of the corresponding metal phosphide. But in silver, we get the PPT of the silver only. We didn't get the PPT of the silver phosphide we get the PPT of the silver, and along with the PPT of the silver, we get HNO3 and H3PO3. What we get? We get HNO3 and H3PO3. So this is the reaction with the metallic salt solution, and these are the chemical properties of the phosphine. So first, basic nature, second, combustibility, third, decomposition, fourth, reaction with the Cl2, and fifth, reaction with HNO2 and HNO3, and sixth one is the reaction with the salt solution. Now, if I talk about the uses of phosphine, the first use is to produce Holm signals in sea, in the ocean. Means suppose if you are stuck in the ocean and there is a ship which is approaching to you and you want to give a signal to that particular ship, then phosphine is used in that particular signal. How? The container, means through which we will produce the Holm signal, that container contains two things. What are two things? That container contains one it contains Ca3P2 and another it contains CaC2. The container through which we produce the Holm signal, that container contains a mixture of Ca3P2, that is calcium phosphide, and calcium carbide. As soon as we saw ship, then we'll throw that container in the ocean, we'll throw that container in the sea. When this mixture come in contact with water, it produces PH3 plus CH triple bond CH, that is acetylene. When this come in contact with H2O, that form PH3 and the acetylene. This PH3 contains some amount of P2H4. This PH3 contains some amount of P2H4 which readily catches fire, and due to this fire, this heat, it ignites acetylene. So what happened? In the container we have a mixture of calcium phosphide and calcium carbide. When it come in contact with water, then it forms PH3 and CH triple bond CH. This PH3 contains some amount of P2H4 which catches fire readily, and due to that temperature, what ignites? It ignites CH triple bond CH, which burns with a glow, and that glow serves as a signal, and that signal is known as Holm signal. So without the formation of PH3, we didn't get P2H4, and without P2H4, it is not possible to ignite acetylene, and it is not possible to produce a glow in the sea. So in this way, PH3 is used to produce Holm signal in the ocean. Now, second, what is the second use? To produce smoky screen. Now, what do we mean by smoky screen? Now the container, if I want to produce the smoky screen, the shells containing Ca3P2 are exploded with the warships. Means the warships which we have, we explode the shells which contain Ca3P2. Means in this, the cells containing Ca3P2 exploded with warship. When Ca3P2 exploded with warship, then this Ca3P2 come in contact with water. Due to the water, this Ca3P2 get converted into PH3, and when PH3 come in contact with air, it produces a white dense fumes of P4O10, and this white dense fumes results in the formation of smoky screen. So the shell containing Ca3P2 is bombarded with the warship, is exploded along with the warship. It is exploded. Due to its explosion, it come in contact with the water, Due to come in contact with the water, it get converted into phosphine, and when phosphine come in contact with air, then it form a white dense cloud of P4O10, and that dense cloud serves as a smoky screen. So in this way, PH3 is useful in a very important purpose. For a very important purpose. So these are the chemical properties of the phosphine, and these two are the uses of the phosphine. So students, that's all for today. In this video, we have covered preparation, physical properties, chemical properties, and the uses of the phosphine. I'll see you in my next video with new topics of nitrogen.